So we're back again, and the usual reminder, if you look at the bottom of the YouTube video, under the description, we've got the index for this meeting and a link to our composite index that goes back several years. And you just search that and find what you want, click a link there, and it'll take you right to the video. And there's also at one time I was indexing the old ROS agriculture stuff, and you can find a link to that there. And there's like a link to the Slack channel, and there's some other fun stuff. You can go look at that. So moving on, last week I was saying I got my, I had my 350 milliamp LED driver boards, and those were working. I could hook a 1 watt LED directly to those, and it would light up, and it was giving me 310 milliamps instead of the 350 milliamps that they claimed it was going to be. And I think they probably did that on purpose just to keep it lower than the max, so you don't burn anything out. And then I ordered some of these 700 milliamp drivers. So those showed up on like Monday or something of this week. They showed up earlier this week, and they put out 630 milliamps. So again, they're not the full 700 they claim, but if you divide 630 by 2, you get approximately the 310 that the other boards were. So again, I think that was just, they did that on purpose. And I was able to connect one of those boards to my 10-watt LED and push 630 milliamps through that. And it's pretty damn bright on the 10-watt LED. And one of the things I tried, I wanted to find out, if I do a series parallel combination of LEDs, because I wanted to have 4 1-watt LEDs and put 2 in series. If I use the red ones, those are 2-volt LEDs. So if I put 2 of those in series, it gives me a total of 4 volts is required to drive that string. And if I put 2 of those in parallel, it's still going to take 4 volts to drive it, but now the current is going to be cut in half, because each half of that is going to take half the current. So I was going to take my 700 milliamp driver. It's pushing 700 milliamps. It goes to that parallel string. So the top string will get 350 milliamps, and the bottom string will get 350 milliamps. And the ones that are in series, they'll have 350 milliamps, all the way across. Now, I could just wire all 4 of those in series and run them off a 350 milliamp board, but that's going to exceed my voltage, coming in from my battery system. So if I have if I have the red LEDs, the red and the orange are both 2-volt LEDs. So if I put 4 of those in series, that's going to take 8 volts to light that up. And my battery system on my vehicle, being a lead acid battery, it's going to go from 8 volts up to 15 volts, depending on the time of day and your mood and the temperature. And when you're charging, it'll go up to 15. And when you run it for a long time, when you get down to about 8 volts, you should declare that it's dead and stop, so you don't destroy your battery. So if the minimum of that at 8 volts and the LED needs 8 volts, well, then it's probably not going to work, because you're going to have some drop over that constant current board. So I might be able to sneak by on that and get the red and the orange to work that way. There might be less wiring and less playing around, and I could use the cheaper. Those boards were cheaper because they came directly from China. And then, but if I go to the blue or the green or the white, those are 3-volt LEDs. So now 3 times 4 is 12 volts. So now I'm all the way up to 12 volts that's required to just get them to light up. And since my range of my battery goes from 8 volts up to 15 volts, there's going to be, half the time my LEDs aren't going to light up. So that's why I was looking at putting the parallel combinations on that. So just by, I could wire some of them all in series and others in series and parallel, but I decided, no, I'll just wire them all the same and it should work, and just put a 700 milliamp driver on all 5 colors that I have. And the reason I have 5 colors, I've got that little round 1-watt LED that's RGB and W. So they've added an extra white LED. So that gives me 4 base colors on that LED. And then I've got a separate one that's just just plain old orange. So that's my 5th color right there. And if I just wire all those up, I figured, I started off, I was going to test this. I get like Al's test, where he went outside, put his thing in the sun to see if he could see it. I thought, well, I'll do the same thing. I'll hook all 5 LEDs up and hook up 5 driver board, hook it up to an Arduino, and I can, flash them and run the intensity up and down just as a test, so I can put it outside and look at it. And I was ready to start soldering pins on those boards, and I realized the holes, because the board has 4 holes. It's got 2 holes at one end for the incoming power and 2 holes at the other end for the LED power. And I was looking at those, they got little holes drilled in them. I thought, well, I'll just solder header pins in those and stick those onto a proto board. When I started looking, I realized those are not on 10th inch centers. So if I do that, that's not going to plug in. That's not going to work. And I thought, well, I could just put stiff wire through those holes and solder it, and then I can kind of manipulate a little bit and get it to plug into the proto board or into a perf board. And it should be close enough to do that. And then the other thing, I can just cut little short wires. And I thought I was going to bring my toys over, and I didn't. So the bottom of the board looks like this, where you got the 4 holes in the board, and 2 at one end are for the LED, and the 2 at the other end are for the incoming power. And the top just looks like this. This happens to be a 350 milliwatt driver, or 350 milliamp driver board. And the other boards that I got look identical, except the capacitors, instead of being black, they're green. And then the inductor, you probably can't read this. The old inductor said 400 and well, whatever. They had one.
Is there a dimming pin on that?
Yes, there is. That's yeah, they call it PWM. So yes, there is. And then what I found out was, since these holes don't line up with the proto board, I was just going to solder pins in there and stick it right on the proto board, but that won't work. So one of the options was to do like this, where I just simply cut these little wires about an inch long, and I can just lay it on top and then stick these right into the proto board or into my perf board or whatever, and just let the board kind of flop around. I'd like it to be a little more secure, so I could just make these a lot shorter, make these like an inch long. And so like this, and that way it's going to hold it in place a little better to do that. But then I had to go through, I had to cut a whole bunch of wires, then have to strip a whole bunch of wires, and I have to solder them all on. And somewhere along the line, I decided, well, it's, I just want to light something up. I could just go back to what I had originally. And I had well, that's not in my, oh, that's somewhere else. But, I can basically just take what I had originally. I just had, say, a perf board. I had a smaller one or a solderless breadboard. I had one smaller than this. What I did, I just simply laid this on the table and plugged these in like this. If I can get in there. Come on. So this board was just laying on the table like that, and then plugged in like that. And then, of course, I don't have my 1 watt LED that I wanted. So anyway, I just had, wires coming off here and hooked up to an LED over here. And then I put power on it. So actually, I guess I had both ends of this plugged into the proto board, and then I just ran wire to my power supply to run that. And that gives me everything that I need to prove that works. And in fact, I did that before and hooked it up to a Arduino. And here, this wire sticking out the side here, this is the PWM. That's the PWM pin coming off the thing. So it's got the 2 power leads and the 2 LED pins, and that's a logic signal that you can either put it full high or full low, and it's either on or off, or you can PWM that and go from 0 to 100% PWM on these particular boards. And then also this board, as I say, this is the 350 milliwatt one, and the 700 milliwatt one looks exactly the same, except the capacitors are different color and the inductor has a different number on it, but otherwise they work just the same. So that gives me the option, if I'm trying to do the 1 watt LEDs directly, I could use just a standard board like this, the 350 milliwatt. If I want to go to a bigger one, so you can buy the single ones that also has a 3 watt LED. So technically I could just hook that up, and those would run directly. But if I want to do the series parallel combination, I want to use the 700 milliamp boards and just hook them up, and I think everything will just work. So anyway, I got to the point where I could, just take that outside with the LED hanging off the side and put it on something and run it. Except I noticed my 12-volt battery that I was going to use for that seems to have died on me. So I'm going to figure out something different on that. And then here's the this happens to be that can I get this to focus today? Come on.
There you go. Yep.
Okay, quit talking. Okay, so there's the RGB LED, and I think the trick is you have to hold it real still. Anyway, so it's got 2 leads for each LED on there, and then by the time you wire it up, you end up with this big rat's nest of wires coming off. But that's just the way it's going to have to be. And these, the old ones I had, which were RGB, they were common anode devices. So instead of having 8 leads coming off, there was 4 leads coming off the LED, and that way I had the common anode was just tied to my 12-volt supply, and then the other 3 to control the colors came off, and I ran each one through a resistor and a transistor to turn them on and off, and that's how the current system is working. So that the new one will just simply have, you know, so to run my whole thing, I was going to have like five of these boards, and then have on my box here. Again, I don't have the right part, but I bought a new die-cast metal box on Amazon. This is bigger than my last one. My last one was pretty tight to put stuff in there. And then basically I can just put, on the side of it. I think what I can do, I was looking at, I think if I drill 2 holes, because it's got kind of a weird pattern to it there. It's got these little notches in it. So what you can do is you can drill or tap holes and then screw it to the side of this box here. And then if I do that, if I just put a dab of thermal compound on the back of that and then screw it down, then the box will act as a heat sink also. So if I put, say, the RGBW here and then the orange one over here, just like that's basically what I had on my previous one, except I didn't have the extra white LED in there. And then if I do that, see on each end of the box, on each side of the box, then you can see it from any angle. I really like to get the one where I just have one LED pointed up and then put some kind of reflector lens type thing on it. But if I do that, the whole point was I wanted the here, hold on a second here. Okay, switch back. There we go. So that's what the original box looked like. And that's like 2 inches by 2 inches by 1 inch tall or something like that. And it turned out the point I couldn't put the LEDs straight up. I had to turn those at a slight angle to get them to fit. I assume those are just glued on there. I don't remember how I did that. So anyway, that's what the old one looked like. And then my new box is I think it's like 4 inches by 3.5 inches, and it's like two inches tall or something. And then what I was doing, I had the GPS antenna was bolted on top of this. So there's a bolt that has to go down through this box to hold it. And then the antenna sets up here. And that way you can still see all 4 sides of the box from anywhere. And the GPS still has a full view of the sky by doing that. So if I have one that just pointed straight up, I have to either get it away from the GPS antennas or not mount the GPS on top of it, because that, physically that's just not going to work. So that I kept thinking about that stuff and decided if I build the new one in this bigger box, just like the old one. And then I could theoretically, I got enough room in here to put all the driver boards right inside of here. And if I really wanted to, I could put like an Arduino inside of here and just have like say a USB cable coming off the side and a battery lead going in. And then I could just talk to it over USB and the whole thing would be self-contained. So that's it. I was going to say kind of like Al's, but I guess we haven't seen his yet. So we'll look at that later. Anyway, I gave up on the idea of doing a full test on my ones just as a test, because I decided I didn't really see the point. So what I could do, and to check the different colors, which I lost them. So here they are. Anyway. So anyway, since it says 4 colors in it, I could just wire them up one at a time and set it outside and say, does that color work? Looking at it directly into it full power, is it going to be visible from anywhere I want to be? So I could just go down the line and just hook up the red one and test it out, and then go back, hook up the green one and test it, and so forth, all the way down to my orange one, and that will tell me what I need to know there. So as I said, I gave up on that first experiment, and now I think I'll just start on the box and start drilling holes and mounting stuff and see how far I get with that. So that's where my lighting project is for the moment. Now, the next thing that came up was last week I was saying I bought these boards from actually it came from China. So it's a board that looks like that monitors your AC power, and on this end it's got digital lines on the thing, so it's a serial interface, and on the other end you got to have this current transformer. And this one happens to be what they call a split core transformer. The first one I bought was a solid core, which means you have to cut the power lead put this over the power lead and then splice the power lead back together. This one allows you to just clip right onto onto whatever you're trying to measure. So my second attempt here, here's just a little short power cord that's I think it's rated at 10 amps. I think it's got 18 gauge wire in it. So I stripped the insulation back. So if I just take my transformer and clip it on to either the black lead or the white lead, it doesn't really matter which one it is, just clip that on there, and that takes care of the being able to plug this in the wall and then plug my load into this end. And so whatever I want to monitor, I can, and then just put the transformer. So like a size reference. Here's the cord, and there's the wire. Say that's gonna have to go on like that. Just clip it on there, and that's all I have to do at that point. And then this board also wants your main power, so I just cut a cord off of something that's got. I made sure it had a polarized connector on it, polarized plug, because in the United States, one of the tabs is wider to represent one or the other. I don't remember which one it was. And then I just got that plugged into my board over there. So basically, when you're done, you can plug this one into the wall, which goes this way, I think, and then you can plug this one into the other outlet, and that gives you the power to run your board, and then it gives you the power to run your load. So that's much easier to do than what I did before. So I spent forever trying to figure out how to hook it together, make all this stuff work. And I bought another one of these boards, and it came in a plastic box, because it turns out once you get this far, well, now you got this board that's hooked up to 110 volts AC, so it could just easily kill you without even thinking about it. So you need to put that in something. So I think about taking maybe a plastic box like this and just laying it in here like this. And then the board has 4 mounting holes. And I figured that the mounting holes by the logic down here, I could just put metal screws in and not worry about it. But down here by the AC, I'd like to either put nylon screws in or just not hook those up at all. The 2 screws at this end would probably hold it down. But down at this end, if I have enough screws, I could use nylon screws all the way around. That'll hold it in. And number one, that keeps from flopping around on the table. And then if you happen to have the top like this, then I can put the top on it, and that way it's self-contained and not much exposed on that. And if I really wanted to, I could bolt, say, a Raspberry Pi to the top of this box to keep it all self-contained, and just hook it up that way. So that's kind of where I'm at on that project. And I've got the other one that had that 3-foot extension cord, and now it's got the board in the plastic box, and it came with a USB to TTL converter cable. So what you do is you just plug that in instead of these 4 wires I've got here. So this one just has the 4 wires that could go to any microcontroller or a Raspberry Pi or whatever, or you can unplug that and plug in their adapter cable, and plug right into, in my case, I plugged it into a laptop. And there's a guy that's got a GitHub that says, oh, here, load this Python code, and it'll just work great. So I went down that path and poked at it. And yeah, it turns out it does work just great. And if I say, let's see how I can do it. I can say share screen and screen 2. And so this thing right here is the thing that comes up and shows you what's let's see, let's make sure. So that's not showing, is it? Damn it. Why does that not show?
We see a graph with a red and blue line.
Yeah, but you're supposed to be seeing this. Here, let me try this. Let's come over here.
Oh, there
Let's
was a
see.
Tinctor menu, but it went away.
Okay, well, I got it on the other screen. Let me try this. Share screen 1. There, now do you see that? Let's see, how can I
Do.
Yeah, okay. So anyway, that's what that looks like. And if we do but the thing back here is the program that's actually running. There's something tricky about it. You got to come in here and say you have to kill it from the little red box here. So I'll kill that. And then back here on the stuff, here's the stuff running. So I just simply execute. I just say Python, AC, USB, power meter.py. You tell what port it's plugged into, and I fire that up. And with any luck, and he says, with any luck, well, that's where
We see the Tinctor menu, but you haven't connected yet.
You do? I don't see it.
It's in the top left corner in a with sort of
Oh, it's
gray
hiding
bluish.
behind all my silly things, my chat, my participants. Okay, so there it is. So yeah, it brings up that menu there, and can I make this bigger? Well, no. Let's try this one. Control plus. Now, apparently you're stuck with that size. So it'd be nice if they were bigger, but it's not. So anyway, that's the menu that comes up. And then if I say connect, see it says USB 0, and that is, just like anything else, you plug it in and you go do a slash dev list and slash dev says you got a USB 0. So I fire it up. It's now talking directly to the board, telling me my voltage is 123.5 volts. Current is 1.1 amps because the refrigerator is currently running. I can hear it. It's taking 109 watts to run that, where it's around 60 hertz frequency. The total energy, I've used 118 watt hours. And somehow you can clear that. And I'm not sure how. Earlier today, when I show you the graphs, I'll show you that. When I was able to, I think I had to shut the whole thing down and then start it up again and then came back up at 0. And this last time I did it, it didn't reset to 0. So I don't know what that is. I've got a power factor here of 0.8. And I had somehow, I can magically calculate that between the voltage and the current waveforms coming in. And well, internally they got a microprocessor on the board, so it knows it can monitor stuff very closely and come up with this. That's got all these other things at the bottom. I'm not even sure what they are. Technically, I think you normally don't get those, but this guy put that out somehow. So at this point, if I were to say to connect, now you got this thing here, you can tell it. He's just got this built-in sample rates from half a second, so that'd be 2 times a second, up to 1 hour. So you can set those to anything you want. So if you can do long-term checking, you might want to set it to 1 minute or 10 minutes or something like that. I ran it overnight at 10 seconds. And we'll get to that. Here, I'll leave this at 1 second. Just remember there was a 1 second. And then, could I do this? No, I don't want that one. I want this one. So I bring this one over here. This is the first time I ran it. I just simply hooked it up and said go, and I wonder what that's going to look like. And then I came back. It turned out my refrigerator ran for I think over an hour, or maybe close to an hour, and I didn't catch the beginning of it here. But see, when I started up, it starts the power is tapering down, and this right here, the current and the power are both on top of each other right there. So you can't see it, and the voltage is just a constant line up there. But anyway, that was just to see if it was going to work. I fired it up, then came back and plotted out, and it ends up looking like this. And then I thought, okay, before I went to bed, I fired it up, and that's not the one I want. That's not the one I want. Oh, that is the one I want. So anyway, let's look at this one. And this one is running overnight. So this is at the point here where it's around 100. See on this, the scale is different on the left and the right, but here it's around the 110 watts. And anytime it's high, the thing's running, and when it's low, it's off. And what really surprised me, I've got this weird section in here that's drawing 400 watts instead of 110 watts. And that totally baffled me. And I went and looked at the numbers down here. And if you go look at it at that time period, the current changed from 1 amp up to 3 amps, and the power factor changed from 0.8 to 1. And so I don't know if that's a bug in the board, or if my refrigerator is actually drawing 3 times as much power for that amount of time. It's not as though it just started up, because they're right here. Here, let's look at a startup curve here.
Do you want to guess?
Sure.
It's the defrost cycle.
Oh, yeah, I don't know. Since this refrigerator is new to me, I don't know what all the other parts are, but that could definitely explain that. Yes. So here's one that's so I thought, that startup stuff that I was just looking at, how can I get back to that like this, this, and see when it starts up, I get a little spike on the beginning, and then it tapers down until it shuts off, and it does that over and over. And I thought, well, what does that look like? Because I'm sampling this at what, 10 seconds. You look up here, which you probably can't read, it says time in seconds, and it says 10, 20, 30. So these are 10 seconds apart when I was doing these reading because I wanted it to run all night. And if I go back to this one, this is set to half a second or 2 samples a second. And when I started up, I right here, because I kept going, oh God, would you be able to know if the door's open or not? And it turns out I ran a test just that. It turns out, oh yeah, it's drawing 40 watts because it's got a 40-watt light bulb in it. So right here, I got the thing all set up and I wanted it to come on without waiting an hour for it or half an hour, whatever it takes. So I opened the door, and then with the door open, the thing cooled down, or actually warmed up, and then bang, it kicked on, and it jumps up to around 350 watts is the startup spike as the motor is starting up. And then it goes back, and you can see it. See, it comes up here and then kind of tapers off. And then it goes on for another, it'd go on for another hour or so before it turns off. And you can see the blue and the orange are not directly on top of each other. One is current, one is power. And I think that's something about the power factor. You can take voltage times current and it gives you a number, but then you also have to multiply that by power factor to get the number to come out. So that's probably why those two are different. But anyway, I just wanted to see, when I first start up, what does it look like? And if I could sample it even faster, I could probably get a better sample there. But that's probably the way, without changing the software at all. That's what it's doing, and it may or may not sample faster than that. I don't know. So if I want to do it some other way, which I was going to mention, I'll mention that in a moment, I guess. So anyway, that's something I found out that does work. And one of my concerns was that, boy, that thing sure runs an awful lot. It just amazed me that it seemed like my refrigerator is running all the time. And this plot right here shows that it's on for this amount of time and off and then on and off. And it seems to be runs more than it's off. So I went to the internet and said, well, how often should my refrigerator run? And something I think from General Electric said, oh, well, modern refrigerators, they run most of the time simply because the startup spike is more costly than letting it run. So basically they just have it running most of the time. And I guess you're just supposed to expect that. So that's something that's good to know, I guess, that maybe it's doing what it's supposed to. And the other thing that surprised me, if you go look at it, let's see, I probably can't. Okay, so right here. So anyway, the point is it's drawing around like 110 watts. Well, so when it starts up, it's drawing more, and then slowly works down to this like 110, and then it shuts off. And just for a point of reference, I kept thinking, well, that's if I had a 100 watt light bulb, you screw it in your socket and you turn it on, and it gets really bright and it gets really hot, and that's 100 watts. So everybody can understand what 100 watts is. Well, that's all the power my refrigerator is drawing while the compressor is running. And that again amazed me. I figured it would take, since you're plugging into a 15 amp outlet, I figured it'd be drawing 10 amps all the time, but it's not. It's drawing, because you go look at if you could read this here, it says current, so volts, current. It started off at 1.16 amps, and by the time it's done, I'll come down here somewhere. And when it settles down, it's drawing around like 1.1 amps continuously. And that says that's 110 watts that's drawing. So anyway, just out of curiosity, I've got all the stuff set up, and that's what I'm monitoring. So that's what I've been doing. I started last night when I ran this plot just to see, with it plugged in, is it going to actually work? And I've got the computer I'm using right now. I just got a USB extension cable running over to my countertop where everything's plugged in, and it's all just seems to be working the way it's supposed to. So I'm pretty pleased with that. So I think that's all the stuff. Oh, so then moving on, I was saying I could, let's say, stop share. And the other thing I could do is if I wanted to actually see that startup, I've got these are a different brand of those current transformers. And again, it's one of those split cores, so we can demonstrate it here. It's got a latch on, so you can open it up and see those kind of black square things. That's the end of one core, and then the top's got another core in it. And when you put it together, that just makes a full toroidal core when you put that together. So you just put your wire through it. And so here I was saying that we put on this, we'll just put it on here. So you just take this extension cord and put the wire through like that, and then just close the lid on it. And now it's clipped on there. So basically that right there will read the current of the thing running. And if you use the one that comes with the board, if you get the split core one, it's slightly smaller. In fact, right here. This gives you an idea of the size on those two. If it's doing like that. So they're basically, they're basically the same size. And the blue one I may be compatible. No, it's not, because it has a built-in resistor, something they call a burden resistor. And if you get the ones with the board, it does not have the resistor built in. The resistor is actually on the board. On the board there somewhere. And if you get this one, the resistor is built right in, and that just simply converts the current from the transformer into a voltage, so that it says something that's, I think the standard is, if you're running 100 amps through it, I think this gives you 0.333 volts across this, what looks like an audio plug. So I could hook that up and hook it up to our Arduino and sample at any rate I want, so I could actually watch that whole startup curve if I wanted to. And the other option is those little Hall effect boards you can buy. I don't remember how much they cost, but it just got a little chip on it, and you hook your load up to 2 pins on one end of it, and the other end's got like 3 pins that you'd hook up to an Arduino or something. And that gives you full isolation. So these transformers give you full isolation. There's no contact with the actual power line. And if I get that Hall effect sensor, it's fully isolated on that. I can see up to like 1500 volts or something from one side to the other side of the device. So that'd be another way I can just use that and hook it up to our Arduino. And that one, I don't know if I have to calibrate this blue one. I found a data sheet, and it could be what they tell me. If I just take the numbers, I put them in my equation and say scale it to that, it'll work. But those little Hall effect ones, those are pre-calibrated, and they say put in these numbers, it'll work. And I'm using those on my robot to measure the power. I think it's power going to the motor. Yeah, power going to the back motor, and then I've got a second one to measure the power on the giant RC server on the front. And they work just fine. You just unhook the wire and put this thing in series with it, and then hook the other wires up to your Arduino or wherever you're using to they just read the A to D and scale it to a current, and those seem to work just fine. So the other thing I was going to mention was, say if you had a box, and we'll just use this as an example. This isn't the box I would use. Say if you had a plastic box like this, and then get these what do you call it, conduit clamps. You can buy those at Menards or whatever. So you just basically drill a hole in the box here and bolt it in, and you could do one at this end and bolt it in. And if you're willing to cut your extension cord, so if I just take my cord and cut it in half, I could stick one wire in here and one wire in here and just cut them, so I got flying leads in there. And you could connect those together with a terminal strip or whatever, and then that way you've got room to put your transformer there, and you got wires to hook up to run the AC on the board. So that might be another convenient way to do that. And I'd probably go with a plastic box. I could use a metal box like this, and if you do, then take the green wire and the power cord and bolt it to the frame somewhere, so this is at ground potential, and that way it makes it safer, so you don't kill yourself. You don't walk up and pick it up and realize, oh, it's shorted internally, and now I'm dead. You're thinking, gee, I should have done something about that. So that should take care of everything I wanted to say today, I think. Yeah, I'm looking around for any more toys. I don't see anything obvious. So I guess I'm done, and I'll turn it over to somebody else.
Al.
Okay, let me get sharing turned on here. A while back, I bought this light off of Amazon, 25 bucks, not bright enough to be seen outside. So with help from Jeff, ended up getting these LED drivers. Mine are slightly different from Jeff's. I've forgotten where I sort of spec these out or not, but they're these LD 2635 MAs. And I was also messing around with resistors, but decided I'm just going to use these LED drivers. Put 3 here and drive the red, green, and blue lights, and put one of these 16 channel PWM drivers to drive what ultimately would be 5 channels. So where I'm at with that, I made a post out on Slack and sort of walked through that.
Could I break in a second?
Sure.
Bob, does the audio sound okay for you, or is it?
Yes, very good.
Yeah. And maybe I'm screwed up, but I get kind of a funny raspy sound to Al's audio, but maybe it's just my computer doing it.
I'm
So
hearing
so-
good.
okay, so okay, you can go back to what you're doing.
So anyway, this Slack video I just walked through where I'm at, and what I've spent my time on is building a box and getting my components soldered down, and it's not completely ready yet, but I'll just, so this the lenses will fit inside snugly inside of that sort of channel there. Wires will come down through the center, and the board, actually there's 3 little proto boards configured to sit side by side only because I didn't have one big proto board to use. And what that looks like is that where I've got, 3 of these little proto boards, each to hold different components. 3 of the LED drivers are over here. Mine happen to have the, whatever it is, 2.5 millimeter pins on there. So I soldered down a header and just popped them into that header. Ran the wires underneath, and that's where I'm at. So these 2, I need 2 in order to drive I think it's the red and the green to get yellow. So worked out driving one of those at 100% and the other at 90%, I get sort of a pumpkin orange, which is going to be good enough for me. And let's see if you can, these LEDs are up off of the base by about 5 millimeters. Obviously there's a melting opportunity for melting here, but we'll see how that goes. At the moment, they're not generating a bunch of heat, but over time we'll see. If I see this smoking out in the yard one day, I'll like, well, I guess I have to move on to something that's a little less prone to melting. But that's where I'm at the moment, is still trying to finish up my signal light.
So I have a couple points on that. Number one, you probably don't need a 1K resistor between your PWM board and your driver board. And also that PWM board already has like 220 ohms in series with it, I think. So you probably don't need that resistor, going between those 2.
Okay.
And the other thing was, you're talking about your yellow one again, and the fact that it's a pain to work on. Since you already have colored lenses, it could be you could just put a white LED on each one of those, each levels, and just light up the white one, and then let the color filter change it to the, past the color you want. So that now that you've got it all built, maybe it's not worth thinking about, but
No, it's definitely worth thinking about, because I have another, I'll put another one together for my Texas tractor. So
yeah,
maybe
that way you can eliminate one driver, and you just have, all the LEDs will be the same at that point. Now, when you go to buy your LEDs, you can get them. It says it's a white one, but you can buy them as cool white or warm white or pure white or daylight. And I would think you'd probably want something like a daylight, so it's more, it's closer to having all the colors in it, but I don't know. So that might, but it might be worth an experiment to do that.
Yeah, I'll be honest, I'm getting a little tired of how much time this thing is taking. But, yeah, that's all good input. Never thought I'd spend so much daggone time on this signal light. So
Yeah.
that's it for me.
Hey, Bob, you got anything?
Other than wrecking a Raspberry Pi, let's see, I'll share my screen and start broadcasting. And that's the error message I got. We're overcurrent on USBs. Now, this doesn't have anything plugged in the USB ports. Let's see, I think then I tried booting up with a card and got this and this. And then I experimented with
Bob,
the
just
new,
to clarify, so it boots up. I mean,
Yeah.
because there you've got a full OS running.
yeah, but once it gets here, it goes up, gets the regular screen, but the cursor doesn't move and nothing can control it. And trying to come in from no machine, I couldn't control anything. So then I went to start flash a new card, and I had forgot that they automatically go to the next version. So this is, if you notice the background, this is the new Trixie. So then I was trying to figure out, well, what's the difference between the two? Trixie isn't mature yet. It works. It'll do computer vision and things like that. But the peripherals for AI and stuff like that don't work yet. But I suppose it's coming. So that was that one.
Does your Bluetooth keyboard work?
No, nothing works.
So no Bluetooth, no USB.
No. So then I got concerned about the terminals I was using, the screw down, and with the fiber wires. And so I took everything apart and made sure I tinned all of the fibers. But then I started using more of these lock nuts, and they work pretty good. It keeps pressure on the wire, whereas with the screw down, it's if it wiggles too much, maybe it would come out. So that's the one. And these come in single up to 5. So you can put, like if you need 12 volts going 4 or 5 different ways, you just plug them in. I don't have a good picture of the other one. And then let's see. So that's about it. Now I'll go over to my notes, and I said, well, what's the difference between Trixie and the other ones? And Raspberry Pi Bookworm is still pretty stable, and it can use all the different kind of hats that go for it. Whereas with Trixie, it doesn't yet, but they're working on it. Key differences. There's some kind of a new control center. Now, I haven't been able to see it until I get the new Pi. But some components like that are not yet compatible with Trixie. So they say stay back with Bookworm for now. That's about it for that. Now I'll go over to Mirror.
Keep in mind, you should be able to back up one version and you just go to their website, say, oh, give me the previous version and load that. So you should be able to go back to where you were.
Yeah,
if that's easier than digging into all this new stuff.
yeah, I think it will. Then go to mirror. Where is it? There. And Al ran something through Claude for me. And I hope it comes up here. Yeah, here it is. So the text on the right where you can't see, I'll make that a little bigger. So then I was talking with Al and I came up with a list of questions, trying to answer them myself. And maybe Al could take over here. Here on, I was interested in what the characters mean, like the asterisks, the pound signs, and the minus signs of who generated what. Where is that where a human comes in and puts those in there, or does the program generate them?
Everything on the right is what they will call a prompt. So that's just, these are think of it like you're going to ask a senior developer a bunch of questions. All of this text is, what are you asking Claude?
Oh, okay.
And the formatting is what it's referred to as markdown formatting. So if you wanted to put this prompt up on GitHub or something, this would be how you would bold stuff and highlight stuff. So it's just formatting characters,
Okay. Is
assuming
there,
you're gonna post it on GitHub.
yeah. So is there a hierarchy of the markups, like the 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 asterisks, and then underneath that would be the pound signs, and then underneath that would be the minus signs, or
Yeah, for headings, like under hardware and constraints, you've got two double, we call them pound signs.
yeah.
I mean, that's one heading level. If you had one hash, the heading would look a little bit different. It's just a formatting character, but
Oh, okay.
don't get too hung up on. I'm sorry to confuse you.
Oh,
It's
no, it's
just
not confusing. It's just, I don't
markdown.
understand. It's on my end, trying to, coming from ground zero.
Yeah, it's just markdown formatting characters.
Okay. Um,
And then your other question, scroll down a little bit because I can't, or scroll
oh,
up. I'm sorry, the other way
oh,
to see the questions you had.
oh, yeah,
There you go.
yeah. Um, did, did Claude, offer to merge your iterations? Like if it said, here's something and you find a mistake, you tell it to make a change, would it merge the new solution with the existing one?
Um, it would accomplish what you're suggesting. It wouldn't merge it. So if you posted this prompt on the right hand side
Yeah.
and you then went back and said, oh, I want to change my requirements a little bit, it will republish an answer. It wouldn't, I don't, I've never seen the language merge
Oh, okay.
used, but it would output an answer again,
Okay.
but it would just be a different version of an answer.
Um, and then the other thing was if you go away from the Claude program, go offline and then come back, um, do you have to have a saved file or will Claude remember it and bring it back up again or?
Yeah, that's where part of the reason for giving you this prompt is so you can copy this off into a separate program like you did. I, um, in my, experience, you want to save the prompt, what you asked, and you want to save the output, what it told you,
Yeah,
in somewhere safe.
yeah, like in a
Uh,
text file or something.
right.
Okay. And then when you come back to it, do you reload your text file or is it there?
Um, I think for me, it's there. I mean,
Oh, okay.
there's a history, and the history is saved.
Oh, so you just call up the item in the history file.
Right.
Oh, okay, good. Okay, I think that's about everything I've got.
And so you were asking about error messages or whatnot. I never tried to run the code that this generated,
Okay,
um, only because I don't have a robot that, has
yeah,
is set up like this. So
okay.
it, it generated code that was ready for you to run to test out.
Hmm, okay. Oh, one last thing. Um, there was a question I how I wired up my remote relay, more or less as a kill switch. And let's see if I can find that. Where there it is. So basically, there's a built-in relay inside the remote that's normally open, and then to the left there's a more powerful relay that's normally closed. So if the switch is on, then current is available for the motors. So if I turn that off, I can't get power to the motors, just as a safety thing. So when the little relay activates, it opens up that relay so power can't get to the motors. So I found I had to put in that little switch in there because it would drain the battery if I wasn't using it. So let's see. That's about it.
Did you have a question about that relay and the draining?
No, I'm good.
I mean, Jeff's the double E on the call. I'm a hack at most things.
Oh,
There might be a way to do that so that it doesn't automatically drain.
yeah.
Jeff, do you have any thoughts on that?
Well, I wasn't really paying attention while he's going through that. So,
Oh, okay.
but now when I go back, I have to go back and re-index it so I can listen to all your details there, so I can get back to you if I see
Yeah.
something you should do on that.
Yeah.
I was sitting here plotting out my refrigerator stuff again.
Oh, okay.
So I zoomed in on that here. Let me do this. I forgot how I was doing this. Let's assume it's going to be this one. And let's assume that's going out to the world. Come on, show me. Yeah, I think that's the right one. I can't see. Anyway, I zoomed in on that startup thing, and down here, the fact was when in order to get the refrigerator turned sooner, I had the door open so you can see the 40 watts from the light.
Okay.
It started and jumps up here to some arbitrary point, and it seems to be, I could zoom in on this more to see what it's doing, but it seems like it was pretty determined to stay there. And then at about that point when it started, I shut the door. So I don't know if this is the amount of power it's actually drawing, because 40 watts is only that's not very much. So anyway, I zoomed in on this so I can see that, and I can see that I can zoom in some more just to stretch this out, because it was sampling 2 times a second on this. So anyway, that was just something I realized I could go look at that without putting, without going back and putting an extra Arduino just to sample this at a really fast rate to watch it. And again, this is up around the range where it was when Al said maybe it's your defrost going. So maybe there's something when it first starts. My thought was when they turn the motor on, it's gonna have like a starter relay or something, and that may account for this this big pulse here, and then it just all of a sudden drops off. So it could be, it could even be right at this point. This is the motor and the lights on, and then when I shut the door, then maybe it drops down to here. So that's just more interesting things that I can go track down and try to figure out what's going on here. So anyway,
Bob, on
so
your RPi, do you know what you did to cause the power or the USB to fail?
Yeah. First mistake was I left the battery connected. I should have disconnected the batteries. But as I was carrying it up the stairs, I don't quite have enough strength on my shoulders yet. So I kind of stumbled and set it down easy, but it was leaning into my body. And there are some wires. I have a step down from 12 down to 5 that goes into the 16 channel driver board, and that wire came loose, or those wires came loose, and I had not tinned them. So I think what happened was some of the strands contacted each other, and of course it blew out the step down. But then I noticed I couldn't operate the Pi, and that's when I went through the procedure. I think I asked the question through chat GPT, and it stepped me through. Well, do this, do this, do this, and it suggested that there's the power management chip, the DA9091, was probably damaged.
Mm.
And I checked over on the Raspberry Pi forums, and it sounded more and more like that was the culprit. So I sent out, bought a new one, a new Raspberry Pi 5. This time I got the 16 gigabyte, and we'll see how that goes.
Did the forums mention anybody who will unsolder and resolder a power management chip on there for you?
There was discussion on how to do that, but they looked at the chips. You can get 5 of them for $175.
Holy cow.
Yeah. And then the equipment is another couple hundred. So they say just get a new Pi.
Bummer.
Yeah. So
do you know how much current that your Pi is drawing in this condition? Does it seem to be running normally, or is it drawing a
yeah,
lot?
without the card in it, it was drawing a little over an amp. But after a while, I noticed that the heatsink was really getting hot. So I figured I better not do it anymore.
On the processor, that heatsink?
Yeah. Yeah, that was I couldn't remember if the fan came on, but when I touched the heatsink, it was pretty warm. So I don't know what was causing that. So now I've taken that off, and I'll use it on my new Pi.
Okay. Another thing on your wires, you bring a wire up to a connector and you attach it somehow. You might want to put something, hold the wire down at that point so it's not, the wire's not wiggling around either. That'd be another thing you could do.
Yeah. That whole step down was loose, not anchored down. So when I stumbled and brushed up against something, that probably started the problem. Now I'm debating, well, just do everything down in the garage. But I figure if I move it up and down, if it fails here, it's better here than outside. But I don't want to blow up boards.
Is your garage a heated garage, or is it?
Yes, it is.
So it's not open to the elements then.
No, I don't have to put on my parka. But it is kind of inconvenient because I don't have a big monitor down there. I'd have to do everything through the laptop, and I suppose I should get used to doing it that way. But I'm kind of spoiled on the big TV monitor.
Yeah.
I don't know if I'll get in hot water if I take the monitor down to the garage. Well, that's about all I can think of. I'd still like to come up with a way of easily removing the batteries before I transport it and easily put them back in and still be secure. But I have to give that some more thought.
Yeah, I think that'd be very handy if you could, take them off and put them back at will.
Yeah. So I'll work on that until the new Pi comes.
You might consider getting a plastic battery box. I mean, they sell those
Yeah,
for car size 12-volt battery
yeah.
and keep it from flopping around a little bit.
Yeah.
I'm done too.
Yep, I'm done.
Okay, I'm done too, so I'll stop the recording if I hit the right button here.